Hi everyone, me with another video today. And today I wanted to talk to you about the Enigma encryption process. So in this small video, we'll be going over briefly what is the Enigma, because that's not the focus of the video. I'm sure that for those that came here, pretty much know what the Enigma is. Uh, I'm going to be more focusing more on the encryption process itself. Then we're going to go through the main steps of the encryption process and rotor details. It's very important. And we're going to finish off with an encryption process example. The Enigma was an electronic cipher machine used by the German army in the Second World War. So yeah, the Enigma used a set of three rotors to jumble and cipher the letters. So you would press a letter on the keyboard, then the electrical current will go through each of the rotor would go through the reflector, which was like a static rotor, then would come back and it would light up a lamp in the lamp. Basically. So you would type a letter on the keyboard. It would go through the plug board, which was a direct substitution. The plug board over here. You can just directly substitute any letter for another one. Then it would go through the right rotor, then the middle one, the left rotor, it would go through the reflector and then right back, and then again through the plug board. And that would light up a lamp on the Enigma. When we press a letter, the first rotor over here rotates before the letter enters the scrambler unit. So we would have the first rotor move, and then we would have the current go through each of these. The rotor is sort of folded out. So imagine that this string would fold around and it would form like a rotor. It would form this circle over here. So this is sort of like an unfolded rotor with the window, the rotor window. Yeah, so this is the rotor window. This is the letter that is currently set. So in this example, I've set up the input, which never changes. It's the static little knobs over here. Uh, and then the output, which also never changes, which is over here. And then we have the wiring. And the wiring is inside the over here. So the wiring is the part where the letter gets exchanged. So for example, we would have, in this case, if we press the letter A, it would enter in this position in the input, and it would get sent off to the wiring in this position. And in this example, let's say we took rotor 1, we can see that if we take rotor 1, A would be encrypted to an E. A would then transform into an E over here. So it would get reported, kind of sent off to this index, and that would get sent off to the ring, and then eventually it would give E in the output ring. So as you see, this is a pretty clear way of viewing the motors. You have the the input and the output that never change, and you have the outer ring, which is the stuff that you see over here. This is the letters that we'd see outside, and inside you have the wiring stuff you don't do not see. So in this case, we previously pressed the letter A. Now the motor, as soon as we press the letter A again, it will advance once. It will turn once. So the encryption will obviously change. So we'll have the A entering over here on the input. But since the motor advanced, and important thing, when the motor advances, all of this turns. It's basically, the motor turns, so you have the wiring turning with the ring, which makes sense. So you have all of this advancing one step. And then you have the electrical current coming in through the input, reporting on B on the wiring. The encryption for this would be B, which is gonna give us K, which is going to report to K on the ring and to J in the output. So as you can see, there's like a slight offset between the ring and the output, which is sometimes pretty hard to visualize. So ring setting is sort of like an offset. So it's an offset between the outer ring and the wiring. So the ring setting basically, what it does, it initially our ring is set to, for example, position A. Ring setting would be set to Z. Let me show you real quickly. So yeah, sadly the quality has taken a hit, but I think it's still pretty clear. So we have the same setup. So we have A. So the initial position is at A, but the ring setting is of B. So one. So one offset. Yeah. So when we offset the wiring, we move it back initially. So everything is going to be the same at the start, but we're going to move the wiring one step back. So when we press A this time with a ring setting of 1, it is going to the Z position in the wiring, and the Z encrypts to a J, and the J encrypts to a K, and then that K encrypts to an well, K on the ring gets output on the output ring as K. So the result is K. Now let's go through a detailed example. So we're going to set up our machine like this, and we're going to step by step, we're going to encrypt everything. So I'm not going to use a plug board because obviously the plug board is pretty straightforward, pretty easy. Just replace a letter by another one. Uh, I'm just going to set my machine with rotors 3, 2, and 1, and with the ring setting B, D, C, the initial position of BAB, and the reflector AKWB. Let's set up our first rotor. So rotor number 1, right? The initial position is going to be B. So we gotta move our wiring over here by 1. So we're gonna have the O over here. Quick shift like this. Oh, here we go. O over here, and the O over here, right? So here we have it. So the initial position for the rotor 1 is B. Then we have to set the ring setting, which is C. So we have to move the wiring 2 steps back. Well, it's kind of inverted, so you have to move it 2 steps to the front, basically. So we're gonna have this coming back. Okay. We're gonna have O coming back. Then we're gonna remove the N. We're gonna have the N coming back, and we're gonna have this N over here coming back. Okay. So now we have the initial position and the ring setting set up. Right. So now that we set up the initial positions, we can encrypt. So remember, when we press the button on the keyboard, the rotor advances by 1. So we have to move everything by 1. So we're going to have the P over here moving to the front. We're going to have the N moving to the front. And we're going to have the N moving to the front. Even if we kind of reverting everything, because it's going to make sense. So I'm going to have A according to A, which in rotor 1 reports to E, which reports to G on the wiring, and G reports to E on the wiring, on the output. I mean, motor 2 is the initial position is A, which is how it is right now, and the rig setting is D. So let's shift. So it's rig setting D means there are 3 shifts. So let's shift this by 3. So remember, we're going this way with the ring setting. So one shift, uh, second shift, sorry, and third shift. All right, just gonna copy this one, and here we go. Ring setting is set up. We're gonna have our previous output enter on the input ring. So we're gonna have the E enter through here, which is gonna report to B on the wiring. And B in motor 2, let me look that one up. So B in motor 2 is going to transform into a J. J is going to transform into a M, and M is going to transform into an M. Third order, the initial position is going to be B, and the ring setting is going to be P. So we set the initial position, which is the O is going to move over here, right? The O is going to also move over here, and the O moves over here. All right. So this is the initial position for rotor number 3. Then we have the rig setting. So we move back the O. And yeah, it's kind of repetitive, I know, but just just so it's everything is clear, we repeat these steps. All right. Before we got the letter M. So the letter M will come through here on the encryption thing, the input ring. Then letter M will report to M on the wiring, and that is motor number 3. So the values for, no, for motor number 3 for M, let me look this up correctly, and it is Z. Okay, so we're going to get Z over here. Boom. This reports to A on the output ring and to Z on the output. Same thing as before with the reflector, just that this one just never moves. So we have what we got before. So we have letter Z entering over here, Z reporting over here. Let's check what is Z in the reflector. So the default reflectors are well marked. Z reports to a T, right? So that's cool. Z reports to a T over here, which reports to a T, which reports to a T. The motor never moves. Now we are reversing the process. So we're going to go from the reflector to rotor 3. And rotor 3 was, let me just set this one back up. So we had an initial position of B, right? First position of B. And yeah, so that's gonna, let me just set this one quickly. So we're gonna have this thing move once, and then we're gonna have this thing move once again. Right, okay. As you can see, same thing as before. Initial position of B for rotor 3, and ring setting of, well, 1, but they kind of cancel out. So in reverse, what we're going to have the P entering on the output ring. Then we're going to have this reporting to U on the ring, and back to T on the wiring. So we need to go back in reverse. So what is T over here, right? So we'll look at T on the wiring this time, and that is going to give us a J. on the entry. So we go back to what we have. So we've got T, and that T is going to report to J over here. And that J is going to report to J. And that's going to give us our output. Now, our previous step. So we're on rotor number 2, right? And we've gotten a J last time. So now our input through the output is going to be J. But firstly, let's set up our motor. Our motor was in initial position A, so this doesn't change. And our ring setting was D. So let's just move N to the back. 1, 2, and 3. Sorry. Okay, same thing over here. I'm just going to copy that one. All right. So this is the state of our motor, right? So we're going to have J enter through the output. So we're going to have J, boom, coming over here. 1, 2, 3, 4 before it. So we're going to have J reporting as J. It's kind of hard to sometimes see what they're aligned to. But yeah, J is going to come out as J, which is going to come out as G on the Y. And what does that give us? So motor 2, G, right? So G reversing encryption, we're going to get R. Nice. So G is going to become R over here, and R is going to come out as, I would suppose, U. Yeah. Okay. Now let's set up the final rotor number 1. So let's set the initial position to B, as you can see here. Okay, move the O. No, wait, no, let's first set the ring setting. So the ring setting is of 2. So let's move this over there. So we're going to have NM and M move over there. All right. Now let's set the initial position. So we're going to have O moving over there. Going to have M moving over there. M over there. Okay, and now let's final movement. We're going to move the P because don't forget the rotor turned once previously. So move the N, and here we go. Now that we have the U, the previous letter on the output, so the U comes over in here, which outputs to W, which outputs to U, and let's see what is U. Number 1, U gives us an R, so U gives us an R, so we come through here, gives us an R, outputs as an R. All right. Did a test with an online Enigma machine, and this is the correct output. So we have all of these steps already. So E, M, Z, T, G, and R. All right. Well, that's it for this video then. I hope this was useful. I hope this helped. And peace. I'm out.
Ты занимаешься боксом, красавчик, серьезно. А я помню, недавно мудакам битами ломали кости. Гоняешь футбол, пинаешь мячик в фирменных кедах. А я беру пятихатку, несу и ставлю на...